Hello everyone, in today's lesson I'm gonna show you how to do the post-processing with the SlamGo post. And the raw data here you can see the raw data contain the control point. So in the SlamGo post I will show you how to create a new project and use the one-click solve to do the post-processing. Here is the SlamGo post software. First, we create a new project. You navigate to the data folder, and then our software will recognize all different type of the data automatically. For example, here, navigate to this folder, and as you can see, our software will read all files automatically. So the type of device is SLAM 200, and the work mode is hand. So we select a path to save the result. Okay, and confirm. So because in this data set we have the control point, so before we do the processing, we need to import the control point in advance. Here you can see I have already the order of the control point. So the A001 is the first control point I measured, and A020 is the last control point I measured. So I organized all control points in this notepad file so that you can import this file to the SlamGo post, and then our software will match the control point automatically. So we select the control point data and add the control point. Here you can see you can set some parameter for your control point, like the CRS and the datum tab and the protection tab and the unit. Actually, in North American, maybe or in the US, they'd like use the feet as the unit, but in other country, we like to use the meter as the unit. Also, you can switch the X or Y and Z as the column like this. So actually, this is the east coordinate, this is north coordinate, and this is elevation. You can also select the projected coordinate or only the local coordinate. Confirm. The central median is 117. Okay. And then we can use the 1K solve to do the post processing. So the mapping mode we select algorithm A, and about the 1K solve setting, please refer to another video that we will explain all the meaning of parameter. one by one. So for the orientation, you can select non-rigid and all rigid. For the non-rigid, it will adjust the scale of the result, and then to do the coordinate transformation. But for the rigid, it only does the coordinate transformation. So as that you use the non-rigid to reduce the IMU drift and accumulative error during the scanning. Okay, if you want the coloring point cloud, you can select point cloud. Or you want the panorama, you can also select this option. And then confirm. Our software will perform every step automatically. Then you can. So for now, in the main window, it shows the trajectory and point clouds when you do the scanning. Now we finished the process. And you can see GCP optimized point cloud. And open the readout path. There is a report about the control point accuracy. Here is the overview of the control point distribution and also the relative accuracy about the control point distance and the match point distance. Here is the ground control point accuracy. This is the measurement coordinate. This is the control point in point cloud, and this is the error between these two coordinates